All right. All right, welcome back, everyone. Um, this week, we're going to be learning about containerization, a bit about DevOps as well. And first, let's start with some announcements. Yeah. So PA3, assignment 3 is due tonight, 11:59 p.m. If you have any questions, post on it. The test script is on the textbook. PA4 is released already, and it's gonna be due next Monday as usual, same time. And the test script will also be released in the textbook soon. Office hours, just a reminder there on the syllabus, and be sure to come to office hours if you need help with anything. Need help with like debugging and like solving or like helping to make sure your code is like exactly with according to the API spec, or like helping help with like Postman or stuff like that. And lastly, we have a announcement for the hack challenge. So if you guys recall, the hack challenge is actually part of your like overall grade. And what the hack challenge is essentially like, because we have the iOS course, the Android course design, and the backend course, you will have 1 to 2 members from each course, and you guys will form like a group, and you guys will basically make an app. So from backend, you guys probably have like 1 or 2 people from backend, because backend is one of the biggest courses. So you'll have like probably 2 people from backend, and you'll work together with some front end people. It's like either iOS or Android, I believe. And you guys will be making an app. So a bit of a brief overview of what the hack challenge will like the schedule will look like. You'll have a mixer first, because if you want to obviously find partners from the other courses, you want to find like a designer, you want to find a front end developer as well. So there'll be a mixer coming soon. I believe the date and time is not fixed yet, but because the room hasn't been fully booked, like confirmed yet. But yeah, look out for the mixer. And then we have the hack challenge kickoff. It's like the start of the hackathon essentially. And that will last 2 weeks, right? Is it 1 or 2 weeks?
The whole hack challenge. I
Yeah.
think it's maybe 2 weeks.
I think it's 1 to 2 weeks. More details will come out soon, but at the end of the 2 weeks, there will be midnight office hours. So like people from all the sub teams, all the courses will be holding office hours. It's called midnight office hours. So we'll be holding office hours until like 12 a.m. to help you finish up your app before the next day, which will be the day that you guys will present your app essentially. Yeah, and the finale will be on May 5th. And that's where we like announce the winners, like the winners of different categories, like the best backend, best UI, best app overall, and stuff like that. And there are like lots of prizes you guys can win. So yeah, it's gonna be a fun time. All right, we can
Yeah,
start today's lecture.
cool. Are there any questions like logistically before we get started about the course or anything? I'm trying to think like PA1 grades will be out very soon. We're just like wrapping that up. And test script for PA4 should be out before the middle of the week. All right, so let's get started. This is just kind of where we are in the course. So we've done our routing first, then we learned about databases with some SQL. We learned about relational databases, your one-to-one, one-to-many, many-to-many. And then we went on to abstractions last time. So that was using like an ORM instead of SQL. Today we're moving on to containerization and DevOps, and I'll explain a little bit like what that is throughout this lecture. Before that, just a little bit of review. So last time during our abstraction lecture, we and demo, we went over ORMs. So that's object relational mapping. And basically what this does is it uses objects or classes to interact with the database. So basically we represented tables as classes, and we use SQL Alchemy to do that. And it basically translates SQL to Python or Python to SQL. So we just write Python code and it'll make the SQL queries for us, and it'll do it safely, and we don't have to worry about it. It'll also automatically handle enforcing our reference conditions, and it'll automatically handle our joined tables for us. A lot simpler than with the raw SQL. So we're going to go into a little bit of the deployment process now. So the first thing that we have to talk about is dev versus prod environments. So typically what this means is you'll have 2 different environments where your code is run. The first one will be dev or development. And this is going to be the environment that you're writing code in. So it's okay if it breaks. We want dev to break and we don't want prod to break. So you can write your print statements, you can write your debugging there, and you can safely push to dev or like upload your code onto the dev server without it affecting the production server. And the production server, or prod, is basically the environment that the users are going to be interacting with. So you really don't want to mess that up. That's like the Instagram you interact with. Yeah, so you want that to be basically error-free as much as possible. And you want to heavily test your code before it goes into production. So that's the different environments. So generally, our deployment process is going to follow 4 roughly steps. The first one is going to be compressing our code into a production environment. So that's a standardized environment, and we'll discuss that. That's like basically this whole lecture. The second thing is to prepare our production environment to be run ready. Then we just spin up our server, we get our server running, and then we download our production environment onto our server. So we're going to really be going in depth into this today, but this is a quick overview. So before we get into that, how do we run apps on other machines? And why would we do that? Basically, you don't want your code to be running off of your local machine. It might be obvious, but if it's not, your hardware is very limited, and you also don't want to just have like a computer sitting there the whole day running your server. Also, like if something happens to your computer, your whole server is going to go down. So instead, we're going to be running running our code on another machine or a server. So yeah, that's what we're going to be doing, and that's why we do it. So when I say environment, what do I mean? In general, an environment is going to include an operating system. So that could be like your Mac OS, your Windows OS, whatever, Linux or whatever. It's also going to have your code. So like your app.py, your db.py, all the code that you write. It's going to have any libraries that you need. So that's like what's in your requirements, .txt. And it's also going to have environment variables, which we'll talk about today. Yeah, so this is what I just said basically, but these are examples of operating systems. These are like your code, the libraries, and also Python would fit under a library, and your environment variables. So environment variables are basically going to be all the sensitive information that you don't want anybody looking at your code to see. So this could be API keys, like that you personally have access to. It could also be like usernames or passwords. We definitely don't want anybody else other than the user to see those. And the way that we hide this sensitive information is with a .env file. And we'll basically be defining those variables in a local .env file. We won't push that to GitHub ever. It'll just be on our local machine. And then in the server that we're running, we'll also have a .env that's local to the server. And that will always be hidden from any other users trying to see our code. And getting into like a little bit how that would work. So imagine we were making a connection to Ithaca Transit, one of the apps we have. So we have a host, we have a database, and we have a user and a password. Basically, all these things would be something that you don't want people to see. If you have any like questions about whether you want people to see it, generally you don't want them to see it. Like even if it's just a URL you're scraping from, it's generally safer to abstract that away and not show it to people. But yeah, so we have these 4 things. How would we hide this? So we have this .env file here, and we would just write database or whatever variable names we want, database, username, password. We write them, it's just this format. So export capitalized database equals Ithaca Transit, username, and our password. And then in our code, instead of having like the raw text, we can write os.environ and then the key or the variable. So we get our database username and password, and we're not going to be exposing that to anybody. That's how it works like for this specifically. This is one way to get environment variables. There are other ways, but I think we stick to this in this course. Are there any questions about this? Yeah.
Constructed one database and then extract and then hit it with a not hit it, but obviously if it's a dictionary, have the key and the value, and then requested the key to give the values like so that you can't actually show the value anywhere.
Yeah,
But
exactly.
when you created it itself, do you create one of those, or is that supposed to represent like a whole table of private information?
Are you talking about the .env here?
Yeah.
You can put whatever you want in here. So it could be as many or as little things as you need to be abstracted away. And then you can access any of those from anywhere in your code, and it's fun.
Yeah. So
Yeah.
then when you're exporting it, do you have to export every single one of them that you put?
Mhm.
Or is it like a shortcut?
Yeah, you just write export for each of them. Yeah, it's not like a CSV or something where you could just like list them all. You just have to individually do them. I've never had more than like 10 or
Yeah.
15. So,
Unless you're working on like a really big project, you need a lot. But you can think of like the .env file as like a sort of secret file that you have locally and on the server. So you'll never push it to GitHub, right? Because you don't want anyone to see it. So it's like a hidden file inside your local or server. And then what your code will do is it just it treats it like a dictionary. See, like in this case, you're just like grabbing the one with the value with the key password or the value with the key username. So yeah, it's just a way to hide private or sensitive information in an environment essentially. Yeah, because you don't want to like show everyone all your code. Even like for example, AppDev, we're an open source club, right? All our apps you can find on our GitHub actually. But like all our passwords, that's like in the env file. So you won't be able to see all our passwords. Yeah.
mhm. Yeah, cool. Any more questions? That was a good question. Cool. So yeah, this is basically just a graphic showing what I was saying, but trying to make myself smaller. You'll have a .env on your computer. You also have a .env on the server, and you always want to make sure that those match up. So if you change something in your computer env, you want to go over to the server and make that change, which we'll show you how to do. But yeah, cool. So the small scale approach, basically what we've been doing this whole class is we install our Python, we install the requirements that we need for that project, and we run our app.py. And this definitely works well for what we do, works great for running things locally. But how can we do it for larger applications? We want to include a database. We have more custom package installations, and we have to manually isolate environments. So basically, the setup is very cumbersome. It's difficult. So we need a modular automated solution because we can't really handle all this manually. There's a lot more to think about when you scale up. So the old way that we did this was called virtualization, and that's using a virtual machine. So what that is basically just a computer running within a computer, and you can set an operating system, and you can run simultaneously to the same computer. So I could basically, if I wanted to run like a Windows app on my Mac, I can download an instance of the operating system Windows and runs like the Windows code on my Mac while having the Mac open. And servers use a hypervisor to manage the virtual machines. So this just basically controls all of them and all the operating systems, like all the computers within the computer. So this is like a visualization of how that would work. So we have three apps here, A, B, and C, and they each have their own operating system, which hint is a little bit inefficient because we have to have three operating systems for three apps. And then we have the hypervisor watching over all of them or controlling all of them, supervising them. Yeah. So that brings us on to the more modern approach, which is containerization, which Josh is going to talk about.
Yep. Yeah, so this week we're only basically going to be talking about containerization, which is the better way to run apps on a server or a computer, right? So what is containerization? So there are four steps to doing containerization. So first, you want to compress the code into a production environment. We'll be doing this with like we're going to be doing this with Docker, which we'll show you later. But essentially, you like package or like imagine you can zip your entire code base. You know how you zip folders and like you can send them across email. You can zip your entire code base and you can essentially transfer that around to different environments or like to your friend's laptop to a server, and then you can unzip them and run them essentially. That's like the high level definition. So first you want to compress it, right? And then you want to prepare your production environment to be run ready. So after you zip your like code, you prepare the server you're going to deploy on. You prepare it to make sure you have like I'm just going to give a like random example like prepare Python there. You want to make sure the username and password to log in is all like prepared. And then you want to start your server. Number three, you haven't spin up your server. And then you want to like get the zip file, you want to unzip it and download it, and then you actually want to run it. So that's how you would get your backend, the one that you guys been creating in your assignments. That's how you would get it to essentially run on a different computer, right? So let's start with number one. How do we compress the code in a production environment? So we'll be doing this with Docker, and you'll see like this image a lot. This is like Docker's logo. It's like a whale that's like a shipping container. And we reference this a lot in backend. We have a lot of inside jokes on this, but essentially like containerization, you can think of it as like neatly packaging your code, and it allows developers to like zip it and package code into a standardized unit so you can transfer it around like fast and secure, right? And to use Docker, there are two steps essentially. The first one is to build code into images. So you can think of images as a type of blueprint of your code. So um like when you're creating your backend, first you compress it into an image. So that's like the blueprint, right? And then you run an image as a container. So when you run an image, that will be a running instance of an image, which you will call a container. So a lot of like understanding Docker is understanding the differences between images and containers. So it's really useful to understand like the difference between these two. We'll get more into that, I believe, here. Yeah. So Docker images, they're images built from your source code, like the code you wrote, like the app.py and db.py. That will be built or like compressed into an image, right? And then it's essentially serving as setup instructions for environment. So remember how like every time you want to test your backend, you want to run the test script, you have to first get Python, you want to pip install, right? Requirements, and then you want to run using Python app.py, right? Those three instructions, that's essentially like the instructions to run your backend, right? In this case, it's the same thing. Our image will have the setup instructions for your environment, which are like those three commands, right? And we do that by defining it inside the Docker file. So we have this one file where we have all those instructions. So we use Python, we pip install requirements, and then we run it. We'll show you that later in the demo, but this file is essentially a list of instructions to run your app. So that's the first step. We want to build image, and the command for that is docker build dot. And I believe dot just says you want to build whichever directory you're inside right now. Let me just check.
Yeah.
Yeah, right. Yep. Okay. And to see all the images, this is just to list all the images you created, because you can't have like multiple apps. You remember you're like containerizing a bunch of apps. To list all of them, you just do Docker images, and it will list all of it in your terminal. So yeah, images. We'll have a bunch of metaphors after this, but images are like the blueprint, and containers are the actual running app. And let me get more into that. So yeah, Docker containers, it's you run a container from an image because the image is a blueprint, right? Containers is the running instance. So a live instance of your application. So remember how we had the Docker file from here? Using the Docker file, we'll actually go through the Docker file and build your application to make sure it runs as a container. And you can also define like running instructions with additional flags. Like if you want to, there are many like it's very flexible. You can add lots of like different steps in your Docker file to run with special like conditions or special terms essentially. And to run a container, you just type Docker run. It's quite simple. And to list all the running containers, you do Docker PS. Yeah, we'll show you that in the terminal later on. Yep. Yeah, so here are the metaphors I was talking about. So images and containers, you can think of them as classes and objects. So images are like classes, like blueprints, and containers are like the object, right? So like in Python, you have class and objects. They're like blueprint and the actual object, right? It's also like blueprints and houses, recipes and cakes, because like recipe is the blueprint and cake is the object. And like generally it's the last one, instructions and the product of the instructions. So images, that's like the instructions to create your app, and containers is the actual running app. Any questions on the differences? Usually on like software, like if you want to put Docker as a tool, on your resume for like a for software interviewing, you would they might ask you what this difference between images and containers, because the names are quite abstract. Like what do you mean by images? Um, but yeah, it's good to know the difference. Can I? I'm gonna throw an egg. See.
Sure.
I want just because it's such an important topic, can we get one person to reiterate and like redefine what's the difference between images and containers? Anyone? Yeah.
Just like first some instructions or run it.
Yeah, okay, that's perfect. Yeah, so images is like the instructions and like you compress codes and the instructions, and containers is actually the live running instance, right? You gonna toss it? Right, heads up. Nice toss. All right, let's move on from this. So this is how it looks like. So this is, imagine this as your like computer or server. On the bottom you have the infrastructure of your like your local server or your computer. You have the host operating system. In this case, like if you run it on a Mac, like this laptop is a Mac, right? And then you have the application, Docker. And what Docker does is it essentially manages all your applications for you. So you can see app A, B, C, D, E, F. You can run multiple instances, multiple apps just by using Docker, and Docker will handle it for you. So these are all these apps, they are running instances, so they're containers, right? And they were built from images, like blueprints that we already had. And actually we use some of the courses actually use Docker. If anyone's taking 3410, I don't know, is anyone taking 3410? No? Well, if you've taken 3410, they actually use Docker to like that's where you like write your C code and to run your C code and like essentially standardize the environment for all the students. Because yeah, question? Two different examples of apps. So yeah, I mean, um, something that you guys will be doing in the next assignment is deploying your backend on it as a Docker container. So let's say like app A is your Docker container that's running for your backend. So like your Venmo assignment, that could be one instance, and then app B could be another instance. Like it could be another backend. Um, I believe it could also be like a web server.
We could give an example, maybe
Yeah.
like in this class, we'll mainly be dealing with all of your like assignments or applications will be one container. So that's like an example of an app, like everything that you wrote, all your routes and your database and stuff. But there are times when like, especially for bigger apps, you're gonna have multiple containers for each app. So like one of the apps I'm working on, you have your like main routes running on one container, and then you have this like web scraper running on another container so that they don't interact with each other.
That's a good example. Yeah. Mainly in this class, you'll actually only be running one app because we're just deploying backend. It is a backend class. We're not going to have any front end. It's just going to be one app, just the backend. But we're teaching you this because it's one of the things that like revolutionized DevOps as well in software engineering. It makes it really easy to deploy, and it's just used all over the place. But yeah, so even though we're only teaching you guys how to use one, like to run one container, in general, you can run like a lot of containers. Yeah. Any questions? Hey, another question? Yeah.
So like Docker should include like all the libraries and like for every single different app.
Yeah, we'll show you more later, but essentially each app can have their own dependencies and libraries, right? So for example, like your app A was your Venmo assignment. It would have Python, it would have Flask, right? It have SQLite. Those are libraries for app A. And then, for example, what the scraper thing, for example, if let's say app B is the scraper Sky made, that might have like I don't know what you use for the scraper, but like
JSoup.
JSoup, it was in Java.
No.
Oh, but like yeah, like an example scraper is JSoup. It would have JSoup. It would have maybe it would have Java. It would run on a different operating system maybe. So it's completely isolated. You can have Python on one. You can have Java on the other. So that's the beauty is that you can have like multiple different computers running on your one big computer, right? So yeah, the libraries come and will be downloaded based on the instructions in your Docker file. So remember how I said you have the Docker file with all instructions? We'll show you more later, but those lines will pip install for you. So each one of these will pip install their own libraries. Does that answer your question? All right. Are more questions? All right, I think we're good. Yeah, so what are the benefits of using Docker, right? The first one from the top of my head is that it's used everywhere, so it's good to know this when you're doing software engineering. But then we have these 4 points. It's better application management system. It's awesome for running multiple instances. You don't want to have to like, install and configure virtual machines on the server every time you want to run something, right? Docker will do that for you. It requires fewer resources. It boots up applications faster. Like I think AppDev, like all our apps, we use Docker to containerize it and deploy it. And it's also simplified and more modular because you have every single app in like it's one container. And maybe one more thing I can add here, it's also very portable because one application we use or like one website we use, we'll show you guys after this is Docker Hub. Docker Hub essentially like it's like GitHub, but you can like everyone shares their own their images. So we'll get into that after this. Yep. So that was step one. That was containerizing, right? Step two is to prepare your production environment, your server, to be ready to receive that container, right? So yeah, this is where Docker Hub comes in. It's a cloud-based service. It's just basically the same as GitHub, but GitHub stores files. Docker Hub stores images or like the blueprints for applications, right? So it stores images in private and public repositories. I believe like with a free account, you only get one private repository, but you get like more public repositories. So for example, for assignment, we're going to ask you guys to have one on Docker Hub so we can see it as well. We can grade it. So that's essentially the same as like pushing your code or pushing your image to Docker Hub. And yeah, this is the same metaphor. Code in GitHub is the same like an image in Docker Hub. And this is a necessary medium for a remote service to access pre-built images. What this means is when we're like, I think next week we're gonna talk about deployment. We're actually gonna have you guys rent a Google Cloud server. So you'll have a machine in Google's cloud, and then you're gonna push your local code, your local image to Docker Hub, and from the server, you're gonna pull that image and run it on the server. So the reason why we need Docker Hub for this is essentially like GitHub. It's how we pass on these images and how we pull and push these images to run on different servers. So that's what Docker Hub is mainly for. Yeah, and we'll show you that. We'll show you guys how to do that probably next week, but we'll be using Docker Hub today. Any questions on Docker Hub? All right. Yep. I'm just gonna click through this. There you go. Okay. So the first thing when you wanna like start containerizing is you wanna create your Docker file. You create the list of instructions to run every time you want to run your app. The second is you want to build. You want to build your image. You want to zip your entire code base and the instructions into that little image, right? That little zip file, essentially. Like, don't quote me on zip file. I'm just saying zip file because it's probably more like easily to understand, but we call it an image. So it builds into an image. And then we push the image. We send the image essentially to Docker Hub where it will live, or like it will be stored on the cloud in Docker Hub. And then we go to our server, or like the server we rented from Google, for example, or from AWS. And then we pull that image from Docker Hub. So now we have like, essentially we imported the code that we zipped up and we can open it up and run it. So that's how, this is like the workflow we usually have for deploying projects. And obviously this is something you don't really learn in school, in university. It's quite, when I first learned this, I thought it was really like weird. There's like a bunch of like processes and steps to just deploy an application, but it's really, really useful. So I'll go through it one more time. You create a Docker file, that's all your instructions. You build the image, that's like zipping your code. You push the image to Docker Hub, that's like send or like saving your image inside like Docker Hub. So like imagine pushing your code to GitHub. And then you go to your server, you like SSH into your server, you go into the terminal, and then you just pull the image and you'll have all your code like in a nicely packaged format already. And all you have to do after that is like run it, which we'll show you how to do after this. So yeah, hopefully this is clear. Any questions for this? Good. All right. And yeah, yet another thing we use is Docker Compose. So this is another tool. They all have the name Docker, but yeah, Docker Compose is a tool we use to define and run multiple containers. So like just now we had like A, B, C, D, E, F containers. Docker Compose is a way to easily manage all these containers and deploy them like more simply. So what you do to use this is you use a docker compose.yaml file. So this is like one file where you can define every single application you want to run. So you can have like app A and you can have all the configurations, and you can have app B and then all the configurations under that. You can have app C and blah, 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 blah. So maybe I'll give out okay, let me just finish the slide. So this course works with just one container. Yeah, this course we'll only deploy one container because it's just one backend, right? But we will still be using Docker Compose, because Docker Compose, although it's usually meant to run multi-containers, you can also use it to run one container. Is there a question? Yeah, question? So front end is a bit different. You usually you wouldn't want to run it on like, I guess you could, like, you could have like a web server running in a container, on a separate container. That would work. But there are like many cases. It usually is for our use case, it's usually for backend. I guess you can use it for front end. Yeah, you can, right?
I think, yeah, and I think you would do another container in that case.
Yeah, but yeah, if you're doing backend and front end, you would definitely use two containers. But whether or not I don't think people in front end usually use containers as much as backend people. It depends what kind of front end as well. If you want to, if you're doing a mobile app, that would be in the app store. That would be downloaded to the user's phone. That would be different than a web app. A web app, you'd probably host it somewhere and have like a domain name point to it, right? So yeah, we might have to come to me after class. Maybe we can talk a bit more about this. Yeah, another question?
Separate Docker Compose from like the Docker file.
Yeah, so that's a good question. So we have so far we've introduced two files, right? Docker file and Docker compose.yaml. So the Docker file is just instructions to run every single application. So let me just draw it out. So this was like the diagram we had just now. We have like app A, app B, app C, app D, right? So what the Docker compose.yaml will do is you'll have one Docker compose. One Docker compose to manage all of these running containers. But then in each and every one of these, you would I don't know if putting them inside the container would be the right analogy, but in every one of these, you would have a Docker file. So it'll be a list of instructions like step 1, have Python, step 2, pip install, step 3, Python app.py. Each one of these would have their own Docker files. So the Docker file, let me just write that down. The Docker file is a list of instructions for one container, while Docker Compose is one file to manage the deployment of multiple containers. Does that make sense? Good? That's good, right?
Yeah, yeah.
All right, any more questions? These are good questions. You'll get to understand them more when we actually use them in the demo after this. What time is it?
We gotta be good.
All right. But yeah, so this is one analogy. Like people usually show it as an octopus holding many containers. See in this case, you have Python, we have Postgres, which is a different type of database. We have Flask. That's actually that. I don't know what that is. It looks like a chili. That's actually the symbol for Flask, which you guys been using. That's React, and all of these are we can use containers to work with them. So moving on, the summary before we get into the demo. You define a Docker file to specify the app's required environment. That's to the instructions, right? Then you build the Docker image, you push the image to Docker Hub, and then you define how to run your image or to manage the different containers. In this case, we have one for this class. But you define how to run them in Docker Compose, and then you deploy. So hopefully that was clear enough. But yeah, this is a small part of DevOps. DevOps stands for development and IT operations, I believe, software development and IT operations. So development is building software, which is what you guys been doing. Operations is testing and releasing software. So DevOps is the combination or like the border between these two. So you'll be working with both the last part of creating your app and also deploying it. And the goal is obviously to build and ship your application like quickly and reliably. So like without any bugs, but also like at a fast pace. That's why we use Docker, because it does like it helps us do these two things. And it makes the development and operations flow seamless. So on the next slide, yeah, I have this flow chart. So essentially here, like this is what we've been doing. This semester we tried to get you guys more into like the planning stage. Like you have the planning stage here. So you plan and then you create, right? You create your app.py, db.py, we verify, this is testing. You package, like you containerize, you release it, and configure it and monitor it. And then you keep going that cycle of planning, creating, verify, adding more features and stuff like that. So that's the left part's development, software development, and the right part is IT operations, like ops. That's why it's like DevOps together. Yeah. So now let's get into the demo. Hopefully we have enough time. Sorry.
I'll try and be like quick. I'll
Yeah.
get you out
Oh,
of here
man.
on time.
Was-
No, you're good. We're just gonna quickly go over some containerization stuff. So I'm open to demo 5, which is, yeah, I'll zoom in. Which is just our this is just the starter code. So we don't actually have any routes defined. We're just gonna be like demonstrating here. Wait, this is whatever. This is our starter code, I think, for last time, or it doesn't really matter what this is, but we're gonna be containerizing it. So yeah, the first thing that we have to do, as we mentioned, is build that Docker file. So the name of that is just Docker file. There's no like what's that called? The dot.
like extension.
No extension, yeah. It's just Docker file with a capital D, and I have a little whale to show me that it's working. So I'm just gonna like write it out and explain it as we go. We've never seen this like format before, but I'll just try my best to explain. So the first thing that we're gonna do is get from get our Python installed. So the way we do that is, oh, I have Copilot on, but whatever. So this is gonna get our Python version. So we chose 3.10.5 for this. It's actually like it's gonna yell at me because it wants me to use like an official Python. So you can change the version sometimes, but just for this course, we're gonna be doing 3.10.5. And then also like Python is its own Docker container that we're getting from. So that's like what we're doing here, technically. Python is just another container that we're like importing from. Then we're going to be running. So this run here is a to run a command. So the command that we want to run is make directory, and then we're just going to call it user/app or /user/app. And this is just, I don't know if you've used mkdir before, but it makes a directory or a folder. So we'll make that folder. Next, we're gonna just switch. Yeah, Copilot knows what to do. We're gonna switch our working directory to be /user/app. So now we're in that working directory we just made. The next thing we want to do is like copy our app.py and db.py in there. So we do copy dot dot, and this will copy all of our current directory into the directory that we just made, user/app. So now we have our code. Again, Copilot is carrying, but we're just going to install all of our requirements, right? So as we've been doing always, it's just pip install. Don't do this, we don't want that. -r requirements.txt. So in our new directory on Docker, we're going to be installing all of our requirements. And then the last thing we're going to do is just run it, right? Python 3 app.py. But instead of doing run Python 3 app.py, we're going to do cmd Python 3 app.py. And the reason we do cmd and not run, you get one cmd command per Docker file. So that's going to be like the final thing you do. It'll be running your actual app. The runs before will just be like,
Build time.
yeah,
Yeah.
during your build.
So
And then this will run.
just to clarify, so this Docker file, remember how we want to compress it, right? And then later when we're opening it up, we want to run it in the server, right? So all the run commands, those are during build time. That's when we're zipping or creating the image. locally. So we're gonna create the Docker image here, right, in Sky's laptop, and then later on when we open it up, when we unzip it and try to run it, it will run CMD. That's why there's only ever going to be one CMD inside our Docker file, because that's like how you run your app. Like in the final stage, after you open it up, CMD is what you will run. So yeah, let's go.
So I'll just do the rest quickly, but it's going to be all in the terminal. So to build, again, it's we mentioned it, but it's just docker build dot, and think of that as like git add dot. So it's just going to build everything in our current directory, and it might take like a little bit, but I think it should be like not too bad. Sometimes it'll take quite a while, as you might see. We'll
Also,
see.
don't forget, like when you're using Docker, you actually have to install the Docker application.
Yeah.
It's a local like application on your Mac or Windows, and you have to have the application open when you're trying to create or compress. It's just because like they call it the Docker engine. It's like you need to be running to be able to like work with Docker essentially. Yeah. So
Yeah, so you could also see all the individual commands that we wrote out, and it does it. It will run all of them,
and it
right?
has there's no CMD. See, if you see the logs, there's no CMD because CMD will be ran during when we open it up. So right now we're compressing it. We only do the run commands. So yeah.
Yeah, so if I did like Docker images here, this will list all of the current images. I got a lot going on, but the one that we just made, you can see it doesn't have a name or a tag. Man. Yeah. So it's just none and tag none, right? Created 25 seconds ago. So that's not good. How do we make a name and a tag for it?
Skip the name and just put.
Yeah, sure. So we do that with docker build -t. What is that again?
Repository name is like your
it means that you're gonna add a tag, right? So
your repository name is this Docker hub username slash.
I know, I just meant what is the -t?
Oh yeah, the -t is for tag.
So -t means we're gonna add a tag, and then we're just gonna name it, I think by convention here, then our Docker hub, our Docker username or Docker hub username, and then slash the name of our application. So I'll just name it demo5 here. And then we need to have docker build dot, right? So we'll docker build, give it the name, and then dot. But we're gonna also add a tag here. So the tag is basically a way to mark a image as with like a version. So if we wanted to update it, we could update it and keep the name the same, but update the tag so we know it's the latest version.
Sort of like a commit string in GitHub. You can sort of name it like or like latest version or like updated version or something like that. You can name it anything, but yeah,
So in this case, I'm just gonna name it v1.0.0. A lot of times it'll default to latest, so it'll just mean the latest, like the most recent. So this will build it again. If we did like Docker images, now it's skyslider/demo5, and we have this v1.0.0 tag there. Cool. And then just to run it, we just do docker run, and then we're going to specify a port in this case. So we'll do -p, and we're just going to do 5,000, 5,000. So the first one is the port number we want in our Docker image. And the second one is the one that we're mapping it to on our computer. So we're just going to have them both be 5,000 in this case. And then we're going to do -it, which means that it's interactable. So it'll make the terminal be interactable. And then we just put in our repository name. I can just grab it from here, I think. Whatever. skyslider/demo5, right?
Yeah.
Oh, I have to add the tag. So it defaulted to latest, but we had it as v1.0.0, right?
Yeah.
Great. So now we ran it. Perfect. Yeah, I'm gonna just start the Kahoot now.